Hey, good afternoon, everybody. Did everybody get some lunch? A little bit of time to relax? All right. Well, for those of you who weren't here in the morning, my name's Colin. I'm one of the co-founders of OpenAR Cloud. Thanks so much for coming out today. I'm very excited. Today we have with us the president of the Khronos Group and VP at NVIDIA of Ecosystem, Developer Ecosystems. And he's here to talk to us today a little bit about OpenXR and specifically GLTF, an amazing emerging augmented reality format that we're certainly very excited about. So help me in welcoming Neil Trevett to the stage. If you prefer it, sure.
Hello? It works. All right, cool. Thank you. Thank you for the opportunity to be here. This is my first contact with you guys, and I really want to spend this afternoon learning more about what you're trying to achieve and find out where the gaps are between what Khronos is working on and what you guys are working on, and how we can work together to help close those gaps if appropriate. So what I'm going to do in the next few minutes is give you a lightning tour around what Khronos is doing to give you the context so we can have a good, productive conversation. So for those of you who haven't come across Khronos before, we're a standards organization. We create and define open, royalty-free standards. There are dozens of standards organizations in the industry, everyone from W3C, IEEE, Wi-Fi, all these guys. We all try to have our own specific areas of focus because life's too short to duplicate work, and we don't want to cut across each other's activities. Khronos's focus is creating acceleration APIs. So software, applications, libraries, toolkits, engines can drill down and access the power of accelerator silicon. It might be GPU hardware for 3D graphics. It could be inferencing hardware. It can be vision processing, just parallel compute. All the interesting applications out there kind of need acceleration, and that's what we're trying to enable. We're almost 20 years old. We have 150 members. It's everyone from Google and Apple all the way down to single-person startup companies. And we're open to anyone who wants to join. And participation is the lifeblood of any standards organization. So if any of this is interesting to you, please consider joining and getting involved and have a voice and a vote. So these are the current active Khronos standards. We have a bunch of standards around 3D graphics. We have a bunch of standards around parallel computation. And the two I want to focus on for the majority of this talk are in the middle, a GLTF 3D asset file format. Actually, that's not an API, it's a file format. But we often find that an ecosystem for something like 3D graphics, you need an API and you need a file format. The two kind of go hand in hand as a matched pair. And last but not least, OpenXR, which is a standard for portable AR and VR. But because I'm not quite sure where our connect points are going to be, I'm going to spend just like 2 minutes on these acceleration APIs. Then I'll focus in on the ones I think are going to be the most interesting to you. So I just come from AWE across the street, and we're all talking about how we can get more compute on longer battery life on smaller devices, and it's an often overlooked fact that these acceleration APIs, they're actually a double win. Not only do they make your application go faster because they're an acceleration API, but they're really getting that acceleration through offload. You're offloading a bunch of work from your CPU to your acceleration processor, like a GPU or a DSP or dedicated hardware. And for parallel computation and pixel processing, offload processors, not only faster, a lot more power efficient. And so we've gone the first way around with Pokemon. Everyone was turning off the augmented reality because it sucked your battery. That's because everything was running on the CPU. So next time, I hope Harry Potter uses some acceleration, and I hope they use Khronos APIs to do it. So the Vulkan is the 3D API, the new generation 3D API. Some of you in 3D, I'm sure, have heard of OpenGL. OpenGL was originally created by Silicon Graphics. They handed it over to Khronos. That's OpenGL is over 25 years old. Vulkan is a new generation API. It goes alongside DirectX 12 Metal, but Vulkan is the only one that's non-proprietary and is available across multiple platforms. It's available from all the GPU vendors. It's available now backends for almost all of the games engines out there, and available on all the platforms. Everything from HPC servers down to Nintendo Switch. Magic Leap 1 has Vulkan drivers, and the Vulkan Working Group are diligently putting in functionality into the Vulkan API, specifically for AR and VR, like multi-view rendering and variable rate rendering. That's what we'll use when we get eye tracking in HMDs. But of course, the Metaverse is going to be the web. As we wander around with our beautiful AR glasses, these interstitial experiences are going to be loaded like web pages. In fact, they probably will be kind of web pages. So it's important that we get this kind of 3D acceleration and compute built into the web stack as well as the native stack. So WebGL is a Khronos API. I'm not going to go into all the details, but I'm sure many of you here know your browser is now a full 3D engine. You can say, give 3D commands to WebGL in JavaScript, and the web browser will take care of doing your 3D rendering. And that's been a standard we've worked on for almost 10 years now. The OpenCL is interesting, may be interesting to you guys. Vulkan and DirectX 12 Metal, they're just for GPUs, but increasingly embedded in mobile devices, and the devices you'll see put into HMD, for example, have more than just GPUs. They have multi-core CPUs, they have DSPs, they have dedicated hardware like inferencing engines. OpenCL is pretty much the only framework out there that lets you tap into those heterogeneous resources rather than just your GPU. It's supported by a bunch of hardware people. A bunch of the inferencing engines that are beginning to ship in the embedded in the mobile space, from Intel, Huawei, Qualcomm, TensorFlow and Caffe, the frameworks themselves, TI, ARM, all these inferencing frameworks for on-device real-time inferencing, they're all accelerated by OpenCL. The compilers that a bunch of people are using to compile their neural networks, they compile down to OpenCL. So OpenCL is quite pervasive. You might not be programming it directly, but it's highly likely it might actually be in your stack underneath you somewhere. And of course, there's a bunch of vision libraries that use OpenCL. OpenVX, I'm going to mention with one slide because it's a Khronos API. I think this is the last acceleration slide I have. OpenVX for vision acceleration using a Lego block approach, a high level of abstraction, so you can take a graph built of these Lego blocks, which now can include neural networks as well as your classic vision processing, and your friendly hardware vendor will take care of mapping that graph description into accelerating it as efficiently as they can on their silicon. So you just write a graph and you enjoy good performance. So OpenVX is around four years old. So that's the acceleration stuff. The majority of the talk, I want to talk about GLTF and OpenXR. So let's dive into GLTF. So GLTF, we call it the JPEG of 3D. Up till about a couple of years ago, that was an aspirational hope that it would become the JPEG of 3D. But over the last couple of years, it kind of really has become the JPEG of 3D. There are lots of 3D file formats out there, everything from Virtualizing to OBJ. Now, there are dozens. If you go onto Wikipedia, you'll get a big long list. But back around 5 years ago, we discovered there was this gap. There was no format that was compact, like a JPEG file, easy to process, like a JPEG file, describe full scenes, animations, textures, nice materials. And then OBJ, you don't even get textures. You just have mesh data. And unlike Virtualizing, we wanted it to be runtime neutral. So, a lot of us learned, I think, from the Virtualizing experience that Virtualizing was an okay file format. It was, for its day, but it made a big mistake. It put the runtime behavior into the definition of the standard, which was great for that one vertical that wanted to do Virtualizing type stuff, kind of made it useless for everyone else. So we learned from that. GLTF is just a bucket of polygons and textures and animations. It makes no judgment at all about what you do with it at runtime. You can use it however you wish. Version 1.0 of GLTF was quite targeted at WebGL, so you described the surfaces using GLSL shaders. But really, GLTF really took off with GLTF2, where we made it API neutral. We did that by taking out the GLSL surfaces and using physically based rendered surfaces, much higher quality and much more portable across the different APIs. So now it's being used not just in the web, but a whole range of different native apps. And I'm going to break the illusion here. This thing is not a video. This is actually a 3D model. And this is standard PowerPoint. I don't have a souped up PowerPoint. This is standard Windows 10. You do need Windows 10. But this is a 3D model that you can now interact with in real time. Microsoft have adopted GLTF as their JPEG for Windows 10. It's part of their vision to make Windows 10 a spatial computing platform, HoloLens, etc. So the GLTF ecosystem is growing every day. It's a full-time job just keeping this one slide up to date. And all joking aside, if your logo is not on there and you would like it to be, let me know. I will be delighted to add it. So on the left-hand side are all the tools. So we have the dedicated 3D authoring tools like Blender and Maya and Max. We have the tools like Adobe Dimension, which create 3D as part of their flow, but aren't just 3D. They're part of a bigger picture. There's the VR and AR authoring tools. There's the live scanning apps. There's the format conversion tools and a bunch of tools that Khronos creates at the bottom. All of these tools now can export GLTF directly. On the right-hand side, we have all the engines and apps that ingest GLTF. So all the gaming engines are pretty much, the web engines, lots of the VR apps and engines. Magic Leap, for example, ingests GLTF directly into their environments. A-Frame, AR Core hubs, and Office. I just showed you. Facebook, you can drop a GLTF file onto your wall and it will just pop up as a 3D object. And as I say, this is a growing list. Some of the recent highlights: Blender, which is close to our heart because they're an open source tool now in Blender 2.8. They have direct GLTF import and export. Cinema 4D, very high-end app, has export. Houdini has now import and export. TurboSquid is one of the repositories out there, 700,000 3D models, and they're converting them all to GLTF. One of the ones that may be quite close to this conversation this afternoon, 3D Tiles, which is an OGC liaison, is a geospatial standard that builds on top of GLTF. 3D Tiles puts a lot of on-demand LOD loading and tile management, but underneath all of the 3D assets, when it actually needs something in 3D, it goes to grab a GLTF file. Google have put a lot of effort into a web component, so you can import GLTF models wherever you go, including into AR Core, and Mozilla are using GLTF both in their authoring tools and their engines for AR and VR. The roadmap for GLTF, we're having a lot of requests for a few key features. We're trying to get the balance right, but not moving too fast because we need everyone to be able to keep up. But the big ask is for second generation physically based rendering. Today we have metal smooth type PBR, but people want quite sophisticated PBR now, absorption and attenuation, clear coat varnishes, subsurface scattering, anisotropic rendering. So we've had some excellent contributions from Dassault, who've been doing this for years. And we're developing this next generation model with input from all of the companies that are involved in the working group. And we're working with a lot of the tools vendors too to make sure that they can bring their surfaces, because often they have internal proprietary formats. They want to bring them out easily, in and out, round trip them out in and back through GLTF. So that's a very interesting discussion. And a lot of the discussions about GLTF, by the way, happen pretty much in the public on GitHub. So if you go to the GitHub links in this presentation, we'll just go GitHub GLTF, you'll find it. A lot of the real-time discussions are happening, and we definitely welcome your input. The other big news, some of you might have seen it on the tweets last week. Binomial and Google just last week announced they're going to open source the basis universal compressor and transcoder, both in C++ and WebAssembly. This is something that we've been working on for a couple of years, and they're going to contribute that format, this open source software compressors and transcodes. They're contributing it to GLTF. So it gives GLTF the opportunity to create what we call a universal texture format. Because right now, even in native space and web space is even worse, very often games have to ship with multiple GPU texture formats. It bloats the installation size. It means the developers have to create multiple texture assets in multiple formats, because the GPUs only understand one or two out of the possible menu of hardware accelerated texture formats. So it's been a real pain for everybody. And it's very hard to get everyone to agree on the same hardware format. So we've clicked up one level, and we're now defining a universal texture format that you can encode into an image that's a similar size to JPEG, but has the crucial advantage compared to JPEG is you can transcode it very efficiently out of that universal format into a whole range of GPU native formats on the fly. You never have to decompress the whole image if you don't want to use it. You just use the bits that you need, and that can be done in situ on the fly on an as-demand basis. So we already have lots of these pieces in place. We'll give an update at SIGGRAPH, but I'm hoping we can get this done this year. This complements the Draco-based mesh compression that we already have in GLTF. That's a Google technology. So you'll be able to compress your meshes and compress your textures, in a GLTF file if you wish to. The Google team, the Draco team at Google, they also have point cloud compression. I know point clouds may be of interest in this forum. We don't have compressed point clouds yet in GLTF, but that's like number 4 on our list. And Google have committed to contribute that technology to the GLTF standard as well. Bringing these technologies in as a Khronos standard has an advantage for the industry, because we have a good modern IP framework, and all the 150 members, they're agreeing that if we create and ratify a Khronos spec, they will not assert their patents against anyone who uses that spec. So it's a great protection for the industry and the people that are using these standards in the field. The last update on GLTF, some of you might have seen this. And again, if you're interested, please get involved. The Khronos Group was approached by a marauding horde of retailers banging down the gates saying, we need to use GLTF, we need Khronos to help us standardize the pipeline by which we can create, manage, display, and deploy virtual products. At the moment, it turns out, and this is public knowledge I've discovered, these retailers, now Walmart has 8 million SKUs. So they have warehouses around the country right now scanning in all these different products, and they're creating 3D files. Wouldn't it be cool if the product design tools themselves just gave you, as well as the product, a GLTF file? And wouldn't it be cool if all the tool chains and the retailers, there was enough metadata so you could track and use these products all the way through selling and retailing, servicing, returning these products, and make these 3D products displayable on any endpoint, anything from in-store super duper VR display, everything down to your mobile phone or your web browser. So we have it's about 60 companies now are in this exploratory group. And it's an interesting mix of the retailers and the technology companies coming together. And they're going to be defining things like metadata, probably suggesting some extensions, things that are missing in GLTF for their use case, and creating guidelines, and in general, just letting this whole use of virtual products in AR be ramped up to industrial scale. So it's a very interesting project. And whilst we're in this exploratory phase, we're kind of figuring out what we want to do. It's literally free for anyone who's willing to come under NDA. So if you go to the link, you'll find out how to join. Right, I'm almost out of time. The last piece, though, is OpenXR, which I think may be the most obvious link, but I'm not sure. But it's a close call between this and GLTF, I think. Anyway, we'll find out. OpenXR. That's okay. I'll finish on time. So OpenXR. On the left, we have the current situation, a classic fragmentation problem, where we have all of the runtimes from the different hardware vendors for AR and VR systems, which we call XR, which means all the engines and apps, they write once to one runtime, and then they have to port it, changing their source code over and over again as they want to reach out to other runtimes. It's a classic place where an open standard can really add value. So that's what we're doing. We're defining a cross-platform API with the participation of all of those runtime vendors. So the engine apps only have to be written once, and then they can run everywhere. So this has strong industry support too. We have all the GPU vendors, pretty much all of the HMD vendors. It started out with the VR guys, but now we have Microsoft, the HoloLens team, and Magic Leap, and a bunch of the mobile AR folks participating too. Microsoft have committed to ship OpenXR and HoloLens 2, for example. So the way this works is OpenXR will take care of everything that you need to do in an XR app, apart from the rendering. OpenXR doesn't do pixel rendering, so you need to use OpenXR along with a 3D API, such as Vulkan. We've used Vulkan here because we're Khronos, and that's our API, but you can use it with D3D or OpenGL. But everything else is in OpenXR. So managing the application lifecycle, doing all the kind of the subtle timing, and compositing all the various elements that go into your display, tracking all the various sensors that you have, the pose, your controllers, whatever UI that your device is capable of supporting, and including output haptics. So they're a good match pair. And OpenXR gives the display pipeline all of the parameters it needs to correctly drive the optical pipeline that you have. So that part of your application can be portable too. So we've been working on this since January 2017, and we're almost there. At GDC, which is in March, just a few weeks ago, we released the 0.9 provisional spec. What that means is we think it's done, but we want to give the industry feedback to kick the tires and tell us what we've got wrong before we bake the final 1.0 spec, which is something that we will live with forever. So we're looking to have this done before the end of the year. Some of the announcements that came out with the 0.9, HTC, obviously one of the leading VR vendors, put their strong support. Epic. Tim Sweeney was actually the catalyst that actually caused OpenXR to be created in the beginning, and he's obviously continued to support and saying that he's going to put OpenXR into Unreal Engine 4. Facebook, which is obviously a key vendor, fully supportive. Microsoft, as I say, going to put it into both their mixed reality devices and HoloLens 2. And Collabora, a very strong player in the open source VR space, is fully on board. And we have a long list. You go to the press release, there's a big long list of companies, but these are kind of the most interesting ones probably. OpenXR is, I think it's getting, one of the reasons it's getting strong support is that no one loses. It's a win-win-win. The runtime vendors, they don't have to stop supporting their proprietary APIs, so nothing's going to break, but they have the opportunity to support these additional APIs. And the XR vendors, if I'm creating an HMD, particularly if I'm a smaller vendor, it's a really good way to tap into a large content ecosystem. There's going to be a lot of apps and engines that use OpenXR. They will all run on my hardware if I support OpenXR drivers. And of course, the developers win because they could write once and they run everywhere, so they get to run on a lot more hardware devices. But the most important ones, of course, are the end users, because we're in this kind of Betamax versus VHS right now. You know, if I buy an Oculus system, I look over the fence and say, wow, are those Vive apps going to run on my system? And there's kind of a buying doubt and uncertainty. And with OpenXR, all apps will run everywhere. And I think that'll be a big friction point in the market that we can relieve. Bringing XR to the web, you mentioned that 3D in the web was important. XR in the web is important too, of course. So in the native side of the universe, native apps will typically use one of the leading engines, and the engines will tap down into the native APIs, as we just saw. In the web space, you have engines as well. 3.js, Babylon.js are two typical engines. They go down into WebGL. The W3C, it's not a Khronos standard, but the W3C is defining WebXR, which is kind of OpenXR, kind of exposed up into the web stack. The good news is that we have a good ongoing collaboration between WebXR and OpenXR, so the two are going to work together. So Khronos is kind of fulfilling our role in the industry. We're kind of providing these low-level acceleration APIs. Meanwhile, the mobile vendors are doing awesome work. Apple and Google with ARKit and AR Core, providing these system-exposed AR capabilities with APIs that are really easy to use, and I'm sure many of you have used them. They're doing excellent work pushing the boundaries forward. But of course, they're both proprietary APIs, and they only work on certain systems. OpenXR, the future versions, now we have the full participation of the AR community. We'll be including that kind of functionality in OpenXR, but in a cross-platform API that can run everywhere. I think my last slide here, I put it in, again, just feeling whether this is appropriate or interesting to you guys or not. We've had quite a lot of discussion around XR and 5G, because a lot of the XR apps would really like to do awesome rendering, ray tracing, all kinds of things, but of course the typical head-mounted devices don't have that kind of processing power yet. And 5G raises some interesting opportunities potentially. So there's some interest in what we're calling MEK servers, multi-access edge computing. A box that sits on the edge, in the corner of your room. So for example, we'd have an edge server here and we will be accessing it for our real-time AR devices that we're going to have any moment now. And that, for example, my own company, NVIDIA, is busy building a stack of software built on top of our hardware, exposing some of the APIs that we were talking about, linked in appropriately tool and networking to be a good MEK server. Now, that MEK server would have to reach out into the cloud to bring any 3D assets. If Christine boots up her app and she needs a map of Switzerland, then the MEK server would reach out to the cloud and bring in those map assets, and that GLTF can be used there, perfectly fine. And we've worked to make sure, we think, that OpenXR will actually hide this data routing from the application. So an XR app running on a device that's actually sending its sensor data to the MEK server and receiving back all its rendered pixels from this high-performance server sitting locally is completely hidden. It doesn't really matter to the XR app. Everything is underneath the OpenXR abstraction. So we think that will may be helpful to developers who want to try out this kind of XR as well as the locally processed XR. So that's it. So thank you very much. Was that interesting?
You mentioned at the end that OpenXR, one of the directions is, well, you built it with an abstraction layer to hide it. Do you have a showing where you've drawn the abstraction layer, or can you speak to what's hidden and what's exposed?
We actually have people trying that out right now. So the high order question answer to your question is, you just write OpenXR and you don't have to do anything unusual. You're going to get the sensor data processed and the pixels for composition in kind of the normal XR way. It's going to be kind of invisible.
Without knowing what's available, so it's an abstraction layer covering. How will I know? Can it publish the capabilities or the services that are available?
Yes. we will know where the gaps are. I mean, and whether the application developers want to know they're in running on a MEK server, which I think you're probably correct. They will probably want to know. So they can make application level decisions saying, oh, I can turn on ray tracing now because I'm running on a MEK server. I'm not running on a smartphone SoC.
Same general picture, but not a MEK server is I'm running, I've got something else in my pocket. That doesn't have, may not have continuous power, or they may have maybe intermittent services. Sometimes they're there, sometimes they're not.
Right. So yes, so we need to find out. No one has done this yet. This is still prototyping, and we'll find out where the gaps are. But people aren't going to be forced to have to do a lot of re-engineering of their apps to run on this kind of architecture. We think that's so it's a good baseline, and then perhaps people will ask for more details. Yeah. Yes. Well spotted. Yeah. Right. Right. Yes. So, Apple, I have no insider knowledge of Apple whatsoever, but just from observing their actions, their business strategy appears to be stonewalling themselves off from the rest of the industry as far as possible. And who's to blame them? They're the most successful company in the history of the universe. So, it's not a criticism. That's their chosen business strategy. But it creates a problem for the developers, right? Because the developers now are faced with a fragmented ecosystem. So we're trying to, in many ways, Khronos ends up being the developer advocate, right? Because what we're trying to achieve, portability of apps across multiple hardware, is in the interest, more often in the interest of the software developers than it is in terms of the platform vendors like Apple, who may not want to see all their content run everywhere, right? So we are working. So Vulkan, for example, Apple are not shipping Vulkan, but now we have open source shim layers, MoltenVK, that lets you take your Vulkan app and it translates it all into high performance Metal, and actually works pretty good. So you can have portability onto Metal. GLTF, though, isn't an API, so you can't shim it. It's a file format. So, and Apple has USDZ. This is going back to Steve Jobs and Pixar back in the day. So, the 3D Commerce Group will handle USDZ. They have to, because their remit is to have things displaying everywhere. And the obvious way that we'll do it will have translation in and out of GLTF to USDZ. So if you're deploying a GLTF model, if you're on Android or Windows or Linux, you just go direct display. And if you find yourself, your target is an Apple platform, you'll do the last mile conversion into USDZ. USDZ, I don't think is well, Apple aren't proposing it as such, but even from an engineering point of view, I don't think it's very appropriate as a cross-platform standard. It's a large, complex runtime that would be difficult to have support on multiple platforms. So we're not threatened by USDZ. We think it's very different to GLTF, and we think it's actually easier to cope with than the APIs. We can just translate, yeah, in both directions. Yeah.
So just curious if OpenXR has any sort of support for technologies like asynchronous time warp or space warp, or is that something that's covered under that API layer?
Yes. So again, it's under, just like Christine's question, it's under the hood. You don't typically have to worry how your GPU display system is keeping the latency down to a minimum. There is an abstraction layer, and it's beyond my engineering expertise, but there's a lot of materials on the OpenXR website. I encourage you to go and look at the spec. And there's some presentations out there that go into a lot more detail about this kind of thing than I could ever do. But in the high order question, again, the answer to the question is you do get visibility into what the latencies are, and you do get to control how the composition pipeline works relative to your frame times. So you have the control you need. But if one GPU vendor does their time warping in one way and another one does another way, that'll be hidden underneath the OpenXR implementation. So we're hoping we've got the abstraction layer correct, so you have enough control, but you're not having to rewrite your code, depending on the underlying drivers. That's why we'd love all of you that care, to go and have a look at the XR spec and make sure we have got the balance right. Yep. Yep.
I wanted to ask George, is that you, George? He had a slide up before lunch, and it said one of their goals, and their computer vision folks, establish a standard for a universal descriptor file that's not tied to a proprietary computer vision system, a descriptor file. Is that in the Khronos DNA? Does it belong there, or would an activity such as what he was, I mean, it's hard for you to evaluate what he's talking about based on 5 words I just read off his slide, but just in principle, would a descriptor file be something that the Khronos would pursue or not?
That's a good question. I mean, any company can propose any initiative at Khronos at any time, but the question is it a good fit?
The DNA.
Is it in the DNA? Do we have the right expertise? Do we have the right participation? For this kind of thing, our DNA is 3D, I think, not databases. So, if your architecture is essentially, like I was discussing over lunch, is basically a big relational database, I'm not sure Khronos adds any value to that. And maybe, the link between what we do and what you guys do is we need to make sure that that database can link out to a GLTF file with holding a point cloud or a mesh or whatever you guys need in your architecture. But if we're talking about adding metadata fields to GLTF, if that is part of the solution, so we can link both ways or use the assets standalone in ways I don't understand yet. If that becomes necessary, then that's definitely something we're interested to discuss. The 3D commerce guys have good ideas on what they want to add, and it's very lightweight to add metadata into GLTF for these different vertical use cases. So that's something that we would be delighted to engage on. Yeah.
GLTF. So if there's a way to link the computer vision to the model representation, it's actually one of the key pieces for object recognition that I think is what our friend was talking about.
There is no explicit link right now, but it goes back to the very fundamental design decision in GLTF. We didn't decide anything about the runtime. So if you want to absorb a GLTF file and use it in a vision pipeline as opposed to a 3D graphics pixel generation pipeline, absolutely, that's something that we can do. There's no restrictions on how we use GLTF as an input format or an output format. So it would be a possible link, but it's not something we've specifically done. But again, you know, if we find, oh, if only we had this in GLTF, it would make the VX processing pipeline so much better, then of course, you know, we can send that requirement over into the GLTF group or into the OpenVX group, and you know, we can, you know, if there are people that want it, we can make it happen, because these are all open standards. You know, this, it's controlled by the industry. It's not controlled by any one company.
And then I guess if I could just ask, you know, while I'm on here, it's standards for spatial querying. Like obviously those GLSL scenes get very large, and the standard by which you express, I would like, you know, this view of it at this resolution. If you have any, let's say, thoughts on that, but that's also an area.
Yeah. So again, level of detail, kind of management, and we talked about it a lot inside GLTF. We haven't put anything in there too much yet. There are people like Fraunhofer that have like streaming technology. They've had it for many years. They're actually bringing some proposals over. Again, we're trying to find the right balance between not loading every damn thing into GLTF, because that makes it too complicated. So we're trying to be careful. So far, the way that people have done it is like 3D tiles. It's the LOD management is actually the layer above GLTF. So it's the 3D tiles layer. It says, okay, I have a map of New York and it's 50 million polygons, but I know where the user's looking. So I only need to bring out, you know, this 50K kilobytes worth of GLTF assets, and it has all the indexing and stuff. So it goes and can affect, you know, go to the viewing frustum and get bits that it wants and nothing else. Currently, that's built on top. And so far that's worked for everybody, and it leaves the base standard nice and flexible and unburdened. But again, right, 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 and Khronos likes, that's a great example, and Khronos likes having liaisons, and I know we've been discussing a liaison here. We have a liaison with OGC, and the result was the 3D tile standard that references GLTF. And again, if we find something that we can and should do together, the two groups, you know, Khronos is always fully open to working to make things work for everybody. So.
Yep, and I'm going to ask a question that has a 5-second answer. One of the, switching gears to this slide here, one of the problems that we have is the virtualizing of GPUs. So what is your estimation in terms of a time frame for when we're going to have an industry solution to that we can see broad deployment of? Because that seems to be a pretty general problem right now.
You mean virtualizing GPUs in the cloud?
Yep.
Yeah. There's a lot of work on that. I mean, it means precisely what do you mean by virtualization? I mean, do you mean having, you know, being able to cluster 100 GPUs into one big? Yeah, I mean, they're available in AWS. I mean, and well, actually, they're available in Azure. They're available in all the cloud services. You can purchase GPU instances. I think what we're working on though is, you know, I want to buy 100 instances and have them act like one big GPU. Now that's a little bit more complicated. But no, GPUs per se are in all the cloud services pretty much now. So, and it's pretty awesome actually. I don't know if you ever tried it. You can get like a high performance GPU instance, and you say, I want to install Battlefield 5, which is like a terabyte download, and you go, because it's downloading off the backbone, it installs literally like half a second. And then bing, you're up and running. It's actually pretty cool. So yeah, anyway. But if you have more detailed questions, let me know, and yeah, I can hook you up with the right people. Okay, I think I'm out of time. Yep.
Okay.
Right,
We're
cool.
we're doing a huddle over here to thank you for answering so completely this important question. Thank you, Neil. And Neil's going to be around here for the rest of the afternoon. We're now going to shift gears, and we are going to invite you to have interaction, much I really liked all the networking that was happening during the demos and the lunch and stuff. And we're now going to go back into a discussion mode. And we're going to have 4 breakout groups. We'd like to kind of see a show of hands about interest level so that we can help distribute the largest group into the largest room and the smaller group into a smaller room. So I'd like to see if and who, just, I don't need to know who, but okay, there are 4 alternatives, right? Spatial reality capture, index mapping, UX, all the things have to do with user experience,